All right, great question. Druval, thanks for asking this question. This is awesome. So what they're telling you in this question, and I'm only going to do one version of it. I'm not going to do all of it because it's an assignment. So I'm going to deal with the closed at one end. What they're telling you is that you've got a tuning fork or some source of sound. Let's say it's a tuning fork that is working at 330 hertz, and it's the fundamental frequency for this length of tube closed at one end. So since it's the fundamental frequency, this 330 hertz, it will produce an L1. It'll produce a first resonance length, which we know is a quarter of the wavelength of the sound that is producing resonance in the fundamental frequency. Because that lambda by 4 is always the first length. So whatever length this tube is, let's say it's length L, big L, it is also the fundamental frequency which leads to the first resonance length right there. And we're going to rearrange this equation, and we're going to say that lambda 1 is equal to 4 times uh, the first resonance length L1. Now, what they want you to calculate is say, look, what is the frequency of the tuning fork which will set up the next harmonic? The next harmonic means what frequency will set up a resonance which is operating not in L1, but in L2, the second resonance. And the second resonance looks like this, if you remember from our notes. So now this same length, big L, now for another tuning fork becomes resonance length 2, L2. But resonance length L2 is 3 times the wavelength produced by this tuning fork, it's a different tuning fork, over 4. 3 by 4 lambda, lambda 2. And we're going to rearrange this equation and get lambda 2 is equal to 4/3 of the second resonance length. I'll let you do that on your own. What else do we know? Well, we know that the universal wave equation applies to both of these situations. That the velocity of the first sound wave is equal to the frequency of the first sound wave times the wavelength of the first sound wave. The same is true here. Velocity of the second sound wave is equal to the wavelength of the second wave times the frequency of the second wave. This is a universal wave equation. It doesn't matter what order you multiply things in. 2 times 3 is 3 times 2. Doesn't matter. So what else is true is that the speed of the wave is decided on by the conditions of the air. What temperature is the air? That decides the wave. So we're going to assume that the temperature is the same in both situations so that the two waves have the same speed. Now we're going to use the universal wave equation to substitute this in. All right, I've substituted the next line. Next, what is lambda 1? Well, I know lambda 1 from up here is 4 times the first resonance length. So I put that in. Instead of lambda 1, I have 4 times the first resonance length. Well, what's lambda 2? Well, look, I did the rearranging here. I know that lambda 2 is 4/3 the second resonance length. But each of those lengths are part of the same tube. It's just the same tubes being worked on by different tuning forks. So that means the first resonance length and the second resonance length are both L. See that? They're both L. So instead of having 4 times L1, I just have 4 times L. 4/3 L2, just 4/3 L. Now I can do some canceling. The 4 cancels out, the L's cancel out, and I can rearrange this and figure out that frequency 2 is equal to 3 times frequency 1, or 3 times 330 hertz, or frequency 2 is 990 hertz. So I've only done one of these for you as a model on how to do the others. Now this question here is one of those questions where we really try to work on our mathematical reasoning. All right, it's more than just physics. It's proportion, linking equations together. And stuff like this is not super duper important in your first physics course. But as you move through more and more mathematical courses, more and more physics courses, this type of thinking is really important, right? You set up a situation and you come up with all the equations you can for that situation. You set up the next situation and you come up with all the equations you can for the next situation. Then, inevitably, you need something to link the two situations. They're linked by speed. And then you bring in those equations that you developed in order to do some mathematics in order to get you your solution. So, so this is beyond just studying waves and stuff. This is teaching you how to think mathematically to solve stuff. Important stuff if you plan on moving forward in this. So thank you very much for asking this question. Greatly appreciated, and have a great day. Bye-bye.